I want to study engineering in nanotechnology because I believe science has not been exploited to its limits. Chemistry is the science of experimenting to get answers and solutions. This career involves all the sciences and the maths that I love, with implication to that can amaze anyone. It's difficult, but I was always fascinated by the small things and its possibilities. The calculus can be applied in many possible areas like thermodynamics, magnetism and crystallization, and many other more. But in this case, we will go deep in an example of like elasticity and deflection. In nanotechnology, the length of scales are too small to calculate elasticity in a normal way, so this integral recognizes the range of elasticity in interatomic and intermolecular forces. In most of the cases, the application of integrals is to get data from a graph or calculate the area, the difference, and its movements. But in this case, is to integrate a formula to get a slope and a deflection using integration technique, especially with powers. To get the elasticity and the deflection, we need to use the established formula of differential equation and elastic curve. This states that there is an object and a fixed support, that is the black point. The fixed support gives us some data like the gradient horizontal, that is 0, and that there is no reflection in the fixed support. First, we need to integrate by using the power rule of adding 1 to the power of x and divided by that. And then we need to integrate again using the steps of powers. After that, we need to substitute the dy over dx as 0 because that's the data we have, and solve for a to replace it in the big formula we already have. After we got a, we need to replace it to get b, and we take y as 0 because of the data we have from the support point. After that, we have all the formula and we have a and b, and we replace them to finally get the integrated formula of elasticity and deflection. The second term gives us the slope at 3, and the third term gives us the deflection at 3. One example case is of a cantilever beam that is at 3, this meaning we can use the formula we already got. We need to get the slope and deflection, so we use the second and the third term. The slope is a very small one, and the deflection is negative 0.002 meters. So in the visual representation, the purple line represents the slope and inclination with the force applied, and deflection is what the beam moves. If we watch the visual representation of the slope, we can see an horizontal line that you have to zoom in an astrometric scale to see the shift. This can be applied to nanoparticles to know how to arrange them, their movements, stress, and to know their characteristics and possibilities in supermaterials. In the process, we need to consider more factors, but the integrals are the basis.